That giant tank of water, sitting up on legs at the edge of your town, it's not really there to store water. Storing water is the easy part. You could do that in a hole in the ground for a fraction of the cost. The reason it's up in the air, the entire reason, is pressure. That tower's real job is to push. Every faucet you open, every shower, every toilet that refills, every fire hydrant that blasts, is being fed by the simple weight of water sitting up high. No pump straining in real time. No motor fighting your morning shower. Just gravity doing all the work, quietly, all day. Once you see what that tower is actually doing, you'll never look at one the same way. Here's the one idea the whole thing is built on. A tall column of water pushes down hard, and it pushes harder the taller it is. Stack water up, and its own weight becomes pressure at the bottom. The number is surprisingly clean. For every 2.3 feet of height, you get about 1 pound per square inch of pressure. That's it. So a tank of water sitting about 100 feet up in the air delivers a little over 40 psi at the ground below. And 40 to 60 psi is almost exactly the pressure you want at a house. Strong enough for a good shower, gentle enough not to hammer your pipes apart. So the height isn't for the view, and it isn't really about volume. The height is the pressure. A tower 100 feet tall makes the same pressure whether the tank holds 50,000 gallons or 1,000,000. Fill level barely matters. What matters is how high the surface of the water sits above your tap. Now connect that tower to a web of underground pipes running under every street. Because the water up top is higher than every faucet in town, it wants to flow downhill into all of them at once. Open any tap and water comes out. Not because something is pushing it to you at that moment, but because it's simply falling toward the lowest open exit. This is called a gravity-fed system, and the beauty of it is that the tower feeds everybody at the same time, automatically, with no moving parts between the tank and your kitchen. One tower can pressurize an entire neighborhood or a whole small town. The water level in that tank is basically a promise. Your pressure will stay steady as long as that tank stays full. Which raises the obvious question. If the town is draining it all day, why doesn't the tank just run empty? Here's the part that makes it clever. There are pumps in this system, but they're not the ones fighting your shower. The pumps sit down at the treatment plant or a well, and their only job is to slowly lift water up into the tower. And they do most of it at night. Overnight, when the whole town is asleep and barely using water, the pumps run steadily and fill the tank back to the top. Then during the day, demand spikes. Everybody wakes up, showers, flushes, and the tower keeps everyone supplied at the right pressure without any pump running constantly. And makes coffee in the same 45-minute window. No reasonably sized pump could keep up with that sudden surge in real time. So it doesn't try. The tower does. During the morning rush, water pours out of the tank faster than the pumps refill it, and the tank level drops. In the quiet middle of the day and overnight, the pumps catch back up and top it off. The tower is a buffer between steady, cheap, slow pumping and the spiky, unpredictable way people actually use water. It lets a small pump serve a big peak, and it lets those pumps run at night when electricity is often cheaper. Everything comes back to one rule. It's the height of the water surface that sets your pressure. So the whole design is just a hunt for height. If a town has a good hill, that's the jackpot. Put a tank on top of the hill, and the hill does the lifting for free. That's why so many reservoirs and tanks sit on the highest ground around. No hill means you have to build the height, and that's what the legs are for. Those tall steel legs you picture aren't decoration, and they aren't a pedestal for looks. They exist purely to hold the water up around 100 to 150 feet in the air, so it makes the right pressure. The tank could sit on the ground and hold the exact same water, it just wouldn't push. On flat land, the legs are the pressure. On a hill, the hill is. Same trick, different way of getting the water up high. Here's where the design really pays off, and it's the reason engineers still love towers in an age of electric pumps. The power goes out. In a system that relies on pumps to make pressure in real time, a blackout is a disaster. The pumps stop, the pressure dies, and taps run dry within minutes. But a gravity tower doesn't care. The pressure was never coming from electricity, it was coming from the height of the water. When the grid goes down, the pumps stop refilling, sure, but the tank is already full and sitting up high. Gravity doesn't need power. Water keeps flowing to every home at full pressure straight through the outage, often for a day or more, on the water already banked in the tank. That built-in ride-through is a genuine safety feature. It keeps hospitals, homes, and critically the fire hydrants pressurized, exactly when a storm or an emergency has knocked the power out. The tower turns "we lost electricity" into "we have plenty of time to get generators running" instead of an instant crisis. There's a second reason that tank is often bigger than a town's daily habit would strictly require: firefighting. When a fire truck hooks up to a hydrant, it can pull water at a ferocious rate, far more than a few houses ever would. That sudden massive draw has to come from somewhere without the whole town's pressure collapsing. The tower is that somewhere. A good chunk of its volume is deliberately held in reserve so that on the worst day, there's both the water and the pressure to fight a fire, even while everyone else is still using taps as normal. So a tower is quietly sizing itself for 3 jobs at once: cover the daily peak, hold a cushion for emergencies, and keep enough head of water up high that hydrants blast hard. The height gives the pressure, the volume gives the time. So simple it seems foolproof. It isn't. Here's the honest side: freezing. A giant tank of water sitting exposed in the air is a problem in cold climates. Water that sits still freezes, and ice can damage the tank and block the pipes. Cold climate towers fight this constantly, with insulation, mixing systems that keep the water moving, and sometimes heaters, and it's a real ongoing cost of putting water up in the sky. Maintenance and inspection. That steel is holding hundreds of tons of water 100 feet up, forever, in the weather, and cleaned inside on a schedule, which means occasionally draining a tower and taking it offline. It's a big, heavy, long-term commitment, not a build it and forget it. Geography. Towers make the most sense on flat land. A town blessed with tall hills often skips the tower entirely and buries a big reservoir or tank up on high ground instead, getting the same gravity pressure without building a landmark on legs. The tower is one answer to the height problem, not the only one. And the big myth: people picture a water tower as a giant emergency reservoir, the town's deep backup supply. It really isn't. Most towers hold only about a day of a town's water, and that water turns over constantly, filling every night and draining every day. It's a pressure buffer that happens to be full of water, and the whole point is that the water keeps moving, not that it sits there for a rainy decade. So let's kill the 2 big myths. Myth 1. A water tower stores the town's water. Storage is almost a side effect. Its real job is to convert height into steady pressure for everyone at once. No pump straining against your faucet. If storage were the goal, you'd dig a cheap tank in the ground. It's up in the air on purpose. Myth 2. It needs pumps running to push water to you. It doesn't, not moment to moment. The pumps only refill it, slowly, mostly at night. The push that reaches your shower is pure gravity, which is exactly why it keeps working when the power goes out. That's the whole thing. A tank of water lifted about 100 feet into the sky, so its own weight quietly pressurizes an entire town, buffers the morning rush, feeds the fire hydrants, and rides straight through a blackout, all without a single motor fighting your faucet. Subscribe to Whambox for more how does it actually work explainers.